Virus isolation or virus purification. These are jargon words in virology, and they're not very precise. They mean different things to different people.
Now, Dr. Gallo and Dr. Fauci talked a lot about isolation and purification. Can you tell me what the difference is between the two?
Isolation, what was it?
Isolation and purification.
Of the virus?
Yes.
Well, you isolate a virus by finding the virus which causes a disease. And you purify a virus by making a lot of, just by purifying it so you get a pure virus.
Okay.
I don't understand what the issue.
They interchanged the two, and I wasn't sure
I see.
If it was the same thing or if it was two totally different.
No, it depends on how they use it.
Okay. Can you explain the process of HIV isolation?
Well, didn't Dr. Gallo do that? He actually isolated it. So,
yeah.
Why should I do all of this? This is all textbook stuff you're asking me.
I'm not quite sure what's behind your question about isolation.
I don't want to be your textbook, Okay. I got other things to do.
Isolation is essentially getting the virus from the patient and being able to transmit this virus to another cell to reproduce the infection and to have a continual supply of the virus, and that's called an isolation. Purification is just obtaining the virus free of cellular contaminants or other contaminations, but it doesn't mean necessarily that the virus is infectious.
Well, what's the purpose of the purification then?
Well, to make sure you have a real virus,
How come you guys didn't just show pictures from the gradient?
We first show it from the culture. Just by centrifugation, but not sucrose gradient.
From the pictures alone, though, in culture, you can't prove what virus you found yet.
Of course, electron microscopy is not sufficient to prove you have a retrovirus, that's clear. You need other characteristics like the density. The reverse transcriptase activity is the key. We didn't describe the electron microscopy as a proof. We described the reverse transcriptase activity as a proof it was a retrovirus.
No, reverse transcription is actually very widespread. Something like 50% of the DNA in our cells comes about by reverse transcription. When I said 50%, I'm saying 50% of the DNA came about by reverse transcription, but it's not all retroviruses.
The problem is that they detected non-specific phenomena. Reverse transcription, particles, and we've seen all the problems with particles, and antigen-antibody reactions. And so you can't take a whole lot of things that might be something and turn them into that something. That's the problem. If you're walking down if you walk into an empty space and you find an engine block and a fan belt and a generator lying on the ground, what do you say you've got? Do you know what you've got? Is that a car? Could it be a boat? Could it be a plane? Could it be something someone uses on a farm to lift grain up? It could be all those things.